Alright. Hi guys. I know how much you missed my videos, so I thought I'd put one together for you. So we're going to take a look at the quadratic formula, and I will be back in a little bit to help you with this, but I wanted to get this together for you. So let's get started. Alright. Now for the objectives, what we're going to be doing is we're going to kind of get into it by first we need to be able to identify the value of a, b, and c from a quadratic equation. That's nothing new for us. We've been doing that. So we'll take a look at that. And then we want to determine if a quadratic equation has 0, 1, or 2 solutions. And we're going to study something called the discriminant. And then ultimately we're just going to get to the quadratic formula itself. And that's what allows us to solve a quadratic equation. But we are going to identify the solutions of a quadratic equation, which actually, those are the x-intercepts. Okay. Now, for this, we're looking at the standard form of a quadratic equation, and one of the key things that I want to highlight is the ax squared plus bx plus c equals 0. Remember, a, b, and c are all whole numbers. Well, they should be. A and b are coefficients, values that appear before the variable, and c represents a constant. So let's say if I look at these two, in a moment I'm just going to draw a line to these, but if I wanted to try and identify a, b, and c, this middle one here is tricky because a is 9, but b, that one, you can't really find the middle term. So actually, believe it or not, b equals 0 if it's not there. And then for the last one, c is 81. One thing I didn't stress enough yet, but I want to make sure, please make sure that you see this last part equal to 0. That's one of the key elements of solving. You can't solve if it's not equal to 0. Remember that. Alright, now on this trinomial on the right, we have x squared plus 4x plus 16 equals 0. So if we want to identify a, b, and c after it's equal to 0, a represents 1, the 1 in front of the x squared. B is 4. And c is 16. Okay, so not too much new here. Now, for some of you, if you took a look at this, I want to give you a moment before I just draw the connecting points. But we want to connect the non-simplified column to match the part where now it's equal to 0. And it's at least solved to the point where all three are equal to 0. So let's see. X squared plus 3x, well, here I'll just draw the line. Now, for this last one, remember, if you ever try to simplify that, write it out so that you know when you distribute, you will come out with the one in the middle. Alright. Now, so the discriminant, one of the key things that we're going to be identifying, you have it on your page, but it's really could be hard to see, so if you want to write it bigger, then you might write b squared minus 4ac. And again, that is from the equation ax squared plus bx plus c equals 0. That's the only time we can find b, a, and c. Okay. Now, a couple things to keep in mind. If you were to identify a, b, and c and then solve for the discriminant, b squared minus 4ac, if, it doesn't matter what number, if it comes out positive, you're going to have two solutions. If it comes out as 0, you'll only have 1. And if you have a negative value, then you will not have any, or you'll have 0 real solutions. Things to consider. So let's check it out. Alright, for number 2 here, what we're going to do is try this out. So we'll do 2 through 3. If I want to identify A, B, and C, I need to make sure this equation is equal to 0. And it is, so we can identify A is 5, B is 3, and C is negative 9. So we set up B squared minus 4AC. If I take 3, square it, minus 4 times A is 5 times C is negative 9. When we simplify that, we get 9 minus, and just disregard, I'm getting into more space, but 20 times negative 9, that would be minus negative 180, I believe. I have to pull out my calculator. Now, if you see 9 minus negative, those must become pluses, and we get 189. Okay, but that's only part of it. We need to identify if this is positive, 0, or negative. Now, since this is positive, then we're going to have 2 solutions, as we said on the previous slide, and you could check if you wanted to, but positive answers for the discriminant provide 2 solutions. Alright, let's try it for 3. So we set it up, identifying A, B, and C. So A is 3, B is negative 2, C is 7. Now, again, using B squared minus 4AC, plug in, and here's why I like parentheses, because if you take negative 2 squared, that comes out, hint hint, positive. Okay, so simplifying, we have negative 2 squared, that's going to be positive 4, and then if we take negative 4 times 3, that's negative 12, times 7, we'd get minus 84. Now, if we subtract between those, we get negative 4 minus 84. It's opposite. It's not positive, it's negative. Negative 80. Hey, what do you see? This is negative. Now, the rule on the other side said that if it's negative, then you would have 0, and you could write that, 0 solutions. 0 real solutions. Why is it important that I put real? Well, when you get to Algebra 2, you'll find out what the difference between those. But 0 real solutions. Okay, last one here. Identify our A, B, and C. Okay, A is 1, B is negative 4, C is negative 6. Setting up one last time here, B squared minus 4AC. We're going to have a negative 4 squared minus 4 times 1 times C is negative 6. Alright, and simplifying. We get 16 plus, when you take your negative 4 times 1 is still negative 4, but times negative 6, that will be positive 24. Alright, 16 plus 24 is 40. And again, that is positive. So, we would have dose, 2 solutions, 2 real solutions. Alright, cool. There we have them. Okay, for number 1, we want to find the discriminant. So if we have negative x squared plus x minus 8, again, let's go through the steps. Identify b squared minus 4ac, but only after you identify what a is. We have a is negative 1, b is positive 1, and c is negative 8. Now when we simplify, we have 1 squared minus 4 times negative 1 times negative 8. 1 squared is 1, negative 4 minus 1, or minus 4 times negative 1 is positive 4 times negative 8. That's going to be minus 32. So when we subtract between these, we get negative 31. And again, since it's negative, how many solutions would you have to that problem? There would be 0 real solutions, or 0 solutions. Okay, if you wanted to see that on a graph, we have provided on the next slide. Notice how this does not, if I were to use this as the bar for you need to cross this line to actually have a solution. Well, you can see that this parabola, it goes up, doesn't quite cross the line, and then it goes right back down. So since that does not cross the x-axis, it does not jump high enough, then there are 0 solutions to that. Okay, on to number 2. So identify A, B, and C. Okay, so when we set up b squared minus 4ac, we get 8 squared minus 4 times negative 4 times negative 4. That's a lot of 4's there, or factors of 4 for that matter. Alright, 8 squared is 64. Then we take negative 4 times negative 4 times negative 4. Man, negative 4 cubed. I happen to know, well, negative 4 times negative 4 is positive 16 times another factor of negative 4. It's going to be minus 64. Yes, these do come out even and or equal. And if you take 64 minus 64, we get 0. Alright, let's think back. What did we say when we get 0? Not positive, not negative. Just plain balanced 0. We would have 1 solution. And that is indeed our answer for that. Alright, let's see it in action. So, if you have 1 solution, that is when your parabola only crosses, if you want to use it, or touches your x-axis in 1 spot, because your solution, so to speak, would be the vertex. So there we have 1 solution. Last one, let's try number 3. Okay, now if we identify A, B, and C, we have A is negative 8, B is 5, and C is 3. Setting up our discriminant, b squared minus 4ac, plug in our values, we come up with 5 squared minus 4 times negative 8 times 3. Okay, so we simplify, we have 25. Now, if we take negative 4 times negative 8, that's 32, times 3, that would be plus 96. Alright, so if we add those together, let's see, we have 11, adding the 5 and the 6, and then 2 and 9 is 11 also, so we'd have 121. Now, since that is positive, again, it doesn't matter what the number is. We just need to know a sign. 0, positive, or negative. This is positive, so there are 2 solutions to the problem. Now, how could you have 2 solutions to a problem? When you're working with a quadratic problem or equation, you can get 2 solutions, and that's if your parabola crosses, so it goes up, you have the vertex, which is the high point, the max, and it goes down. But you have 2 spots where you have a solution here and you have a solution over here. So that is how we can get 2 solutions to a quadratic equation, but that's only if you would have 2 places where the parabola crosses the x-axis. Alright, I think we're ready. Ready for the quadratic formula. Here's how it goes. If you're given the equation ax squared plus bx plus c equals 0, you can use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I even made a note at the bottom, it must be equal to 0 if you're going to identify a, b, and c. Absolute crucial. Well, before we advance with this, I think I might try singing a little bit for you. One thing I want to say, well, first, I've had a teacher who, there was a friend of mine in college and she had to sing this for her elementary education class. And I'll give you the tune that she sang. She sang, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I know you'll say something about my singing, but I try my best, so to be fair. But the other way, and I like this story because my fiance is not a Notre Dame fan in the least bit, but her geometry teacher in high school taught her this other version, which is to the Notre Dame fight song. So originally when she sang this to me, I had a field day with it, because she sang x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I want to keep going and singing it, but yeah. So that. All right. So let's continue. Now, with the quadratic formula, something just keep in mind here, it's worth noting. The answers you get when you use the quadratic formula, those are the solutions to a quadratic equation. I was showing you that as we were looking, and then you could actually see what the solutions, or where they were, but now we're going to actually solve. Okay, so using 3x squared plus 14x plus 8 equals 0, we want, and I do want to say before we get started, try to consolidate and just use space sparingly because these are lengthy problems. Alright, now, got to identify a, b, and c. So we have a is 3, b is 14, and c is 8. As we set it up, we have x equals negative 14 plus or minus the square root of 14 squared minus 4 times a is 3 times c is 8, and that's all over 2 times 3. Okay, now as we simplify, I want to get my calculator ready so I can use it as needed. But, okay. X equals negative 14 plus or minus square root of, and we're just going to simplify what we can, which is underneath the radical first. 14 squared is 196. If we take 4 times 3, or however we do this, when we multiply 4 times 3, I know that's 12, times 8, that is 96. So if we subtract 96, then we will have a better answer. But then we also need to divide by 2 times a, or 3, which is 6. So as we move forward, x equals negative 14 plus or minus. Now we can subtract under the radical, square root of 100. And that's all over 6. Okay. So we can take it to the next step. We have x equals negative 14 plus or minus. If I look back at this radical 100 here, what's the square root of 100? 10. Yes, alright, so, and that's all over 6. Now as we get to this step, one thing I want you to keep in mind. We are going to simplify before we actually write this out. So we have negative 14, we have 10, and we have 6. I want to know what all three of these are divisible by before you continue. 14, 10, and 6 can all reduce by a factor of 2. So let's do that. We get x equals negative 7 plus or minus 5 all over 3. Alright. Now that we've gotten to this point, there are two things we can do once it's broken down to where we are. First, you have to get two problems. And let's say if I kind of split these apart for now, I just want to kind of section that off. The first answer would occur if we take x equals the negative 7, and because we have a plus here and we also have a minus underneath, that's a new sign for you guys. It means we can get two solutions. And what we do is we split that up. So we have negative 7 plus 5 all over 3. And we're also going to have our second equation down below. Same exact, well, not, I don't want to say exact, but same thing essentially, only instead of the plus above, we're going to use minus, which was the other sign left over from the problem, all over 3. Alright, now we're not done, because we need to solve those. Negative 7 plus 5 is negative 2. Now, because negative 2 over 3 does not simplify, we'll leave it as negative 2 over 3. Good. But that's gone down as much as possible. And let's answer in part 2. So we have x equals negative 7 minus 5 all over 3. Negative 7 minus 5 is negative 12. So I'll put x equals negative 12 over 3. That does divide. So we should write our official answer as x equals negative 4. And you have solved the quadratic formula. Wow. So, you can see that it's lengthy. But you know, if you just take your time and simplify the radical, the first 3 steps, I guess you could say 4 steps, are all about plugging in the values properly, knowing what you want to simplify first. Remember, the radical looks hideous until you break it down. So simplify the radical first, then you'll get to where we have x equals negative 14 plus or minus 10 over 6. So we divide each part. If all three divide, then you can reduce. But if 2 out of 3 can only divide by 2, then you couldn't. And we'll come to that. And then once you get to the bottom, you want to split it into part 1 and part 2 here because of the plus or minus. And we had 1 plus and 1 minus equation. Solve to get our two answers. X equals negative 2/3 and x equals negative 4. Brilliant. Let's advance. Okay, for number 2, we have 6x squared minus 5x minus 4 equals 0. Now with this, again, we start by identifying a, b, and c. So we have a is 6, b is negative 5, and c, I don't know if I called that b or c before, but c is negative 4. Alright, now plugging them in. It's x equals negative 5. Now what I'm going to do, I don't like a minus negative, so I'm going to make this into a plus 5 in front. It's going to be the opposite, just like how the other day we were doing negative b over 2a. That actually comes directly from this formula. So we have positive 5 plus or minus the square root of b squared, which is negative 5 again, squared, minus 4 times a is 6, times c is negative 4, and that's all over 2 times 6. Okay, plugged it in correctly, now let's go. Okay, so x equals 5 plus or minus. Remember, when you square a negative, it comes out positive. So radical 25 minus, now since I have 4 times 6, that's negative 24 times negative 4. And I believe that one is, well, first of all, a negative times a negative is going to be positive. And 24 times 4 is 96. Alright, now that's all over 12. Moving forward, we have x equals 5 plus or minus. We need to simplify. 25 plus 96. That is 121. And that's all over 12. Okay. We simplify. We have x equals 5 plus or minus. The square root of 121 is, let's take the last two digits here, 11, and that's all over 12. You know the trick with 11, if you're ever trying to figure that out, with like what's the square root, see how you have the 1 and the 1 on the outsides, but if you take 1 and 1 and add them, you get the 2 in the middle. That's a way you can remember that, hopefully. If you remember it, though. Okay, now, we have x equals 5 plus or minus 11 over 12. We want to identify if 5, 11, and 12 share any common factors before we break this into two equations. Since 5 and 11 are both prime numbers, we know this has to be left alone. So I'm going to make our first equation, x equals 5 plus 11 over 12. And let's see, I'm going to make the second one on the right. So we have x equals 5 minus 11 all over 12. When we simplify, starting with number 1, x equals 5 plus 11 is 16 over 12. Now that can simplify or reduce. So if we reduce that, we get x equals 4 over 3. Answer number 1. Now, here's answer number 2 coming up. X equals 5 minus 11 is negative 6 all over 12. Hey, look at that. X equals negative 1 over 2. 2 answers. I understand that they're fractions, but you know what? There's something satisfying about being able to reduce a fraction to get your answer. So, find the successes where they come, because they will appear, and you got to appreciate them. That's the way that you're going to appreciate this stuff. By the way, on the ECA test, you will be able to use a formula sheet, which does have this x equals negative b, well, the whole thing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, lucky for you, you have a formula sheet that gives you all these. Alright. Number 3. We have x squared plus 12x equals 45. Well, how do we get this fixed? Remember, you got to get it equal to 0, so you would have to move the 45 to the other side and make it negative 45. Alright, I already did that for you. Sorry, but I didn't want anyone running into any issues. So, on the worksheet, I won't fix it for you. Just remember, switch sides, I should say, and switch signs too. When you switch sides, you switch signs. There's a phrase. Now, let's identify A, B, and C. A is 1, B is 12, and C is a big one, negative 45. Alright. Now, when we set up our formula, we have x equals negative b. B is 12, so we have negative 12, plus or minus the square root of 12 squared, minus 4 times a is 1 times c is negative 45. And that's all over 2 times 1. Let's get down to business. X equals negative 12 plus or minus the square root. 12 squared is 144. Minus 4, let's see, minus 4 times 1 is 4, times another negative is plus. Now 4 times 45. For those of you who know your stuff, if you take a factor of 2 from 4 and double the 45, you got 90. Now if you double that again, you have 180. So it'd be plus 180, and that's all over 2. Okay. X equals, as we simplify, negative 12 stays the same. We have plus or minus the square root of 144 plus 180 would indeed be 324. Good guess on that, whoever said that out loud. And 2 is going to be our denominator. Does 324, does that simplify perfectly? I want to say it does, and I think it's 18. X equals, that's not one I've used in a while, but I'm pretty sure it's 18. I could check just to be on the safe side, so I will. Don't want to give you any false information. Cool, and we're right. Alright, now, take a look at negative 12, 18, and 2. Do they simplify? Yes, they do. Okay, what do they simplify by? 2. Awesome. So, if we divide all of them by 2, we have x equals negative 6 plus or minus 9 all over 1. Now you don't have to put the 1 anymore, because when you divide something by 1, you just get the top. So let's leave our first equation as x equals negative 6 plus 9. And the second is x equals negative 6 minus 9. Now when we solve those, get our two answers. X equals 3. And we also have x equals negative 15. Much bigger than we might imagine. But, believe it or not, those are correct. Alright, I hope you're coming into your form on these and thinking that, it's not too bad. That's what I'm hoping. Speaking of not too bad, we're going to simplify some radicals. Let's take a look at them together. It's always better when we support each other. Now, if you recall, trying to simplify the square root of 48, I'll tell you it's not a perfect square, so you can't just simplify it. What you're going to have to do is look at all the factors. Let's see. The factors of 48. And this could require, it definitely helps to have a calculator. I know that 48 is divisible by 4, and remember this time I don't want to just use 1 and 48, 2 and 29. I actually want to get perfect square factors, so that's why I'm starting with a 4, because you can take the square root of that. 4 and divide by 4, you get 12. Okay. Now, 9 doesn't go into 48, but 16 does. So if you take 16 and multiply it by 3, we're going to get 48. Guess what? This 16 is a perfect square. Guess what else? 3 is as small of a number as it's going to get. So, if we use those factors, let's say we have radical 16 times radical 3. Well, we're just looking to simplify here. So we have the square root of 16 is 4, and then just drop down the radical 3, and there's the answer for that first one. Okay. Now, for the next part, I want to find the factors of 160. Now, if you have an eye for it, you can see that this does have a number 16 in the problem. And actually, if you know your factors, I mean, if you don't, then we can take a look at it. But 16 is a factor of 160. What's the other factor? 10. Alright. But if you were, say you wanted to make that chart anyway, 160 is divisible by 4 because it goes into 16, and that is 4 times 40. But, again, 160, if you check that, it's not divisible by 9, but it is divisible by 16, and that's where we came up with 16 and 10. If you try to go up, see, remember the factors of 10 are 2 and 5, not 25, 2 and 5. I don't know what's going on. But anyway, so those are the factors we wanted to use. Now, if we have the square root of 16, that is 4. Repeat performance with that. But, again, because we can't, you could write 2 and 5, but 2 and 5 are prime numbers, so you have to leave your radical as radical 10. So we have our answer, 4 radical 10. There's our refresher on working with radicals and simplifying. We'll need to do a little bit of that for these last couple problems. Okay. Now let's set it up. We have 5x squared minus 8x minus 1 equals 0. So when we solve that, first we set up a is 5, b is negative 8, and c is negative 1. So we have x equals negative b, change that to a plus 8, plus or minus the square root of b squared is, well, negative 8 squared minus 4 times a is 5, times c is negative 1, and that's all over 2 times a is 5. Okay, it's set up, let's go. X equals 8 plus or minus square root of 64 minus 4 times 5 is 20 times negative 1 is plus 20. Alright. I like adding. And that's all divided by 10. So, simplifying, we have x equals 8 plus or minus radical 84. And that's all over 10. Guess what? We need to see what radical 84 would factor into. So what I'm going to do, just temporarily, I'm going to look at radical 84. And you could write this in the margin if you want. When you try to factor 84, let's take a look at that. If you look at it, you can tell 4 is definitely a factor in 8 and 4. Okay, the factors of 84 are 8 divided by 4 is 2, 4 divided by 4 is 1. Now, if I wanted to check, here's a quick way to look at this. The factors of 21, only factors are 3 and 7. Those are prime. Good news. This is the only pair you want to work with. Okay. So, we have radical 4 times radical 21. Now, if we simplify that, we get 2, drop down your radical, 2 radical 21. And that's what we're going to be working with. 2 radical 21. Okay. Save that, because we're using it in the previous slide. Okay, so we have x equals 8 plus or minus, no longer radical 84, we have 2 radical 21. That's all over 10. Here's one of the reasons why I've been training you to ask if all three numbers divide by the same factor. Because now I'm going to compare 8 to, disregarding the 21, when you have a radical, you're not going to divide that. You only divide, as I like to refer to it, I call it the coefficient, like the 2. The number outside the radical. So 8, 2, and 10. All of those can divide by 2. Okay, so we have x equals 4 plus or minus. You could put 1, but see, the thing is, you don't have to. You could, it's just 1 radical 21, and that's over 10. Now, some of you will ask, can I put the 1? You can for now. But I need you to understand that when you write your final answer, it's assumed to already be in there. But anyway, we have x equals 4 plus or minus radical 21 over 10. And we're almost there. The easy way to finish this is just write it out twice. We have first x equals, I'm getting sloppy, sorry. X equals 4 plus radical 21. And that's all over 10. That's the first answer. Yes, it really is. The second one, same thing, switch the sign. Alright, so we have part 2 here. X equals 4 minus radical 21 over 10. And finito. So the good thing is, yeah, we had to pull the radical aside, the radical 84, to turn it into 2 radical 21, which we did on the other slide. But, you know, you do that much, then you don't have to solve it entirely all the way, because we can't divide by a radical from a whole number. So, we're done. Almost there, guys. I think we have one more. Yes. So, last one. We have 4x squared plus 2x minus 11 equals 5. Again, make sure you make it equal to 0, so we subtract that 5 from both sides, and that's how we come up with our equation. And in the back, our constant is not negative 11 or 5 or negative 5. It's negative 16. So that way, now we can identify all of our A, B, and C. And that's why it's crucial. You'll get the wrong answer if you don't set it equal to 0. So A is 4, B is 2, C is negative 16. Okay, so setting it up, we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 4 times negative 16. And that's all over 2 times 4. Solving. Okay, x equals negative 2 plus or minus radical 4. Now if you take negative 4 times negative 4, we get minus 16 or negative 16 times the negative 16 in the back. Then we would get plus, and actually that's a perfect square. I want to see if you guys remember it. 16 times 16 is 256, and that's all over 8. Okay, so we have x equals negative 2 plus or minus. When we solve this, we have radical 260, and that's all over 8. Alright, now that we got to the point where we have radical 260, we need to check and see if that is reducible or simplifiable. I like that term. So, set that aside, find the factors of 260. Now if I do, I'm just going to make a little chart on the side. Again, don't try to do this in the sense where you only want to set out perfect squares. So like 4. If you check, 4 goes into this. It's 4 and 65. Now, just to be safe, let's check on the factors of 65. The factors are 13 and 5. Both of those are prime and prime. So since those are prime, we will leave this, well, we're just going to work with 4 radical 65. So, we have radical 4 times radical 65. The 65 part stays the same, but this radical 4 reduces or simplifies. So we have 2 radical 65. That's what we need. 2 radical 65. So now our equation looks like x equals negative 2 plus or minus 2 radical 65. That's all over 8. Aha, this time we have negative 2 plus or minus 2. We have radical 65, and that's all over 8. Now because we have factor 2, 2, and 8, all of these are divisible by 2. So now we have x equals negative 1. You do have to put the negative 1 there because there's nothing behind it. But with the plus or minus, I don't need to put the 1 in front. We can just put radical 65. And that's all over 4. Now that we have a radical in the problem, remember, you're very close to the final answer. First answer, we have x equals -1 plus radical 65 all over 4. Answer number 1 there. And then answer number 2. That's where we have x equals, same thing, -1 but minus radical 65. That's all over 4. Alright, 2 answers. And we solved it. Okay, take your time again. Just make sure, I know there's a lot in one day, but just make sure you simplify properly the radicals. I'll try to provide an answer key for you. If you do have, if you have any questions, I'll be back in a little bit, but good luck and I'll see you soon.